Well, students, Stride here again. Today you got notes for section 4.3. Reading the section, taking notes from there, looking at my video here, taking notes from here. Just make sure you get all pertinent information from 4.3 on how atoms differ. Our objectives, things you're going to need to know as you complete this chapter. You're going to need to be able to explain the role of atomic number and determine the identity of an element, defining an isotope, explain why atomic masses are not a whole number, and calculate the number of electrons, protons, and neutrons in an atom, given its mass number and atomic number. So these are some of the key ideas you need. Review vocab, you got the definition for periodic table here. Sure you remember that. And our main idea. The number of protons and the mass number defines the type of atom, and then we got a few new vocab terms we're going to have. So, atomic number. So, definition, number of protons in the nucleus of an atom identified as the element and is known as its atomic number. So, and then each element contains a unique positive charge in its nucleus. And a periodic table is always going to tell us atomic number. Here it's written here, many times you'll see it. Up here or here. So all elements or all atoms of a particular element have the same number of protons and electrons, but can have different number of neutrons. And atoms with the same number of protons but different number of neutrons are called isotopes. So, most elements are a mixture of isotopes. Relative abundance is normally constant. So, like in a banana, we have 93% of potassium-39 and about 7% of potassium-41, just a little tiny amount of potassium-40. So, another banana or potassium, it's going to be the same. So, this is what potassium is made up of. Isotopes having more neutrons have greater mass, but isotopes have the same chemical behavior. Mass number, the sum of the protons and the neutrons, is 39 here, 40, 41 is our mass number. Atomic mass unit, 1/12 the mass of a carbon-12 atom. An atomic mass unit is really close to 1 proton or 1 neutron. So a proton has an atomic mass of 1.007 and a neutron just slightly heavier at 1.008. The atomic mass, or what I prefer, I'll use average atomic mass of an element, is the weighted average of all of the isotopes of the element. And this little chart shows you a little bit of how it's calculated. We take the mass of one isotope times its percent abundance, mass of the other isotopes times their percent abundance, and then we end up adding them all together. And this will match the value we find in the periodic table. So there's a quick overview of section 4.3. If you add anything else from your reading, do it, and from what you hadn't covered on Hummer Notes. And a couple quick review questions. An unknown element has 19 protons, 19 electrons, and 3 isotopes of 20, 21, and 22 neutrons. What's its atomic number? And atomic number is always going to correspond to that number of protons. Mass number is going to be 19 plus 20, 39, or 19 plus 21, 40, or 19 plus 22, 41. So, number of protons. And elements with the same number of protons and different number of neutrons are called It's just our definition for isotopes. So, that's 4.3. Till next time, this is Strike.